Have you ever thought about how the modern world keeps things separated?
Yeah.
Imagine if tomorrow every single industrial separator on Earth just suddenly stopped spinning. Just a complete global halt.
Oh, it would be an absolute nightmare, a total system failure.
Right. Within hours, municipal water systems would just back up and turn to sludge.
Yeah, and pharmaceutical production lines would just freeze mid-batch.
Exactly. Our energy grids would stall out, and, the dairy products in your fridge would never have made it past that raw, unpasteurized phase.
It's wild to think about because we never actually see these machines. They are hidden away in these massive concrete facilities and steel plants.
But high-speed industrial centrifuges are literally holding modern civilization together.
They really are. It is the invisible engine of the modern world. We interact with the finished product every single day. The clear tap water, the concentrated pharmaceutical compounds, the pristine food ingredients, yet we completely ignore the intense, highly mechanical, and frankly violent processes required to isolate those pure elements from a chaotic, mixed-up raw state.
And to understand how this isolation actually happens at a global scale, our mission today for this deep dive is to look at a genuinely fascinating source we've received.
Yes, the Dream App Works catalog.
Right. It's an exciting business announcement and a highly detailed product catalog from this company detailing their Decanter Centrifugal machine supply services.
And it is a remarkably dense document for what is ostensibly a catalog.
Yeah, so throughout this deep dive, we are going to look at what these highly specialized mechanical beasts actually do, the surprising and wildly diverse global industries that rely on them, and what it truly takes to supply them.
Because it doesn't just list machines with a price tag. It inadvertently maps out an entire industrial ecosystem. By analyzing the highly specific equipment the supplier offers, we really get a masterclass in how global infrastructure actually functions behind closed doors.
Okay, let's unpack this. Because right out of the gate, the catalog throws some heavy engineering terminology at us based on the models listed.
So definitely.
It lists horizontal decanter centrifuges, two-phase and three-phase models, along with high-speed and low-speed options.
Right.
So before we look at where these machines are going or who is buying them, we really need to understand the underlying physics. When the text says decanter centrifuge, what kind of machine are we actually looking at?
Well, if you were to look inside one of these massive steel tubes, you'd find a masterclass in exploiting gravity. To put it simply, a decanter centrifuge is a machine that uses continuous, extreme centrifugal force to separate solid materials from liquids in a slurry.
Or separating two liquids of different densities, right?
Exactly. So imagine a large horizontal cylindrical bowl. Now imagine spinning that bowl at thousands of revolutions per minute.
Wow. So we are talking about creating a massive amount of artificial gravity here.
Immense artificial gravity. Think about an astronaut. During a shuttle launch, they might experience 3 or 4 Gs of force, feeling, 3 or 4 times their body weight pressing them into their seat.
Right, which is already a lot.
Yeah. But inside one of these industrial decanters, the materials are subjected to anywhere from 2,000 to over 3,000 Gs.
That is insane.
It is. And as the messy, mixed-up slurry is pumped into this spinning bowl, that immense gravitational force pushes the heavier, denser solid particles outward, slamming them against the inner wall of the bowl. Meanwhile, the lighter clarified liquid stays closer to the center.
Okay, that paints a great picture of how things get pinned to the wall. But it raises an obvious mechanical problem for me.
What's that?
Well, if you just spin a tube and pin all the heavy mud or solid waste to the outside wall, eventually the tube is just going to fill up with solid rock-hard cake, right? How does the machine actually get the separated stuff out without stopping every 5 minutes to be cleaned?
That is the genius of the internal design, and it comes down to a component called the screw conveyor.
Okay.
Inside that spinning outer bowl is an auger, basically a giant screw, that is also spinning. But here is the critical detail. It spins at a slightly different speed than the outer bowl. We call this the differential speed.
Oh, interesting. So if the outer bowl is spinning at, say, 3,000 RPM, the screw inside might be spinning at 2,980 RPM.
You've got it.
Yeah.
If they spun at the exact same speed, the solids would just get permanently stuck to the wall, like you pointed out.
Right.
But because the screw is turning just slightly slower or faster than the bowl, its blades act like a continuous scraper. It physically carves the heavy, compacted solids off the wall, plows them up a slight incline, and pushes them out a discharge port at one end of the machine.
Oh, wow.
And simultaneously, the lighter, clean liquid flows over a damp plate and out the opposite end. It is a continuous, non-stop process of pulling materials apart and discharging them in opposite directions.
That mechanical differential is brilliant. And I think it helps make sense of the next major distinction in the catalog.
Yeah, the phases.
Right. The supplier makes a very specific point to offer both two-phase and three-phase decanter centrifuges. Let me try an analogy here to help visualize what those phases actually mean in practice.
Sure, go for it.
Think about trying to aggressively separate a messy bottle of homemade salad dressing.
Okay, a classic example.
Right, so if you have a bottle with just oil and water and you want to separate them, that's a two-phase separation. You are separating one liquid from a second liquid of a different density.
Right.
But let's say you've added heavy, solid crushed herbs and garlic into that dressing. Now you have a three-phase separation problem. You need to pull the heavy solid herbs out while also separating the light oil from the heavier water.
That perfectly captures the physics at play.
Ah,
And translating your salad dressing analogy to the industrial scale gives us a really clear view of why both models are necessary. Well, a two-phase centrifuge is incredibly common in municipal water treatment. You have wastewater, which is the liquid, and human waste, or dirt, which are the solids. You extract the solid cake out one end and the clean water out the other. Two phases.
simple enough. But the three-phase models are where the really complex chemical processing happens, I'm guessing.
Right. A three-phase centrifuge is the backbone of an industry like olive oil production, or as the catalog explicitly notes, oil and gas separation.
Oh, yeah, the catalog mentions that.
Think about an oil drilling operation. The raw material coming out of the ground isn't pure crude. It is a chaotic, boiling slurry of crude oil, underground water, and heavy abrasive sand and rocks.
Yikes.
Yeah, so you need a highly calibrated three-phase machine capable of augering the heavy sand out the solid discharge, while simultaneously using precisely placed liquid skimmers to separate the floating oil from the sinking water, discharging them through two completely different liquid outputs.
Man, understanding that sheer mechanical complexity makes the next part of their product list really stand out.
It does.
Because looking further down the catalog from DreamAppWorks, I see they offer both high-speed and low-speed decanter models.
Yes, and that's crucial.
And I actually have to push back on this a bit because to me, it feels counterintuitive. If this entire process relies on maximizing G-force to separate materials efficiently, why on earth would an industrial plant ever intentionally buy a low-speed model? Doesn't a faster centrifuge always mean better separation?
What's fascinating here is that speed isn't just a dial you turn up for better performance. Speed is entirely dictated by the physical reality of the material you are processing.
Okay, that makes sense.
The catalog gives us a huge clue by listing sludge dewatering decanter centrifuges right alongside oil and water separation decanters. Those present two wildly different threats to the machinery.
Wait, threats. So it's not just about getting the job done faster, it's about the survival of the equipment. If you spin certain materials too fast, do you risk destroying the centrifuge?
Oh, you turn a multi-million-dollar piece of equipment into shrapnel. Let's look at sludge dewatering. This is the heavy, abrasive, thick material found in mining operations or municipal waste. It is full of silica, grit, and rocks.
Right, heavy stuff.
If you take a dense, highly abrasive sludge and spin it at absolute maximum ultra-high speeds, the friction generated against a spinning bowl would be unimaginable. You are essentially putting heavy clay and rocks into a blender.
Just grinding it down.
Exactly. The sheer weight and grinding force would cause catastrophic wear and tear on the machine's internal components. The screw conveyor's scraping edges would be sanded down to nothing in a matter of days.
Ah, okay, that makes perfect sense. For heavy, rocky sludge, you don't want a sports car, you want a tractor.
That's a great way to put it.
You need a low-speed, incredibly high-torque approach. You need the raw mechanical muscle to churn and slowly push that dense mud out of the bowl without tearing the steel apart.
Exactly the right way to view it. Now look at the opposite end of the spectrum, oil and water separation. Here you are dealing with two liquids that might be tightly emulsified.
So they're blended together on a microscopic level.
Right, on a chemical level.
Right.
You don't have any heavy abrasive rocks to worry about grinding down your screw conveyor. But to break that chemical bond, to force the microscopically bound oil to physically tear away from the water, you need an astronomical amount of centrifugal force.
Ah, I see.
That physical reality demands a high-speed model. The physics of the slurry always dictates the engineering of the machine.
Which provides the perfect context for why this supplier highlights custom-built decanter centrifuges and complete skid-mounted decanter units.
Yes, exactly.
Because you clearly can't just buy a one-size-fits-all spinner out of a warehouse. By the way, for anyone listening who might not be an industrial engineer, a skid-mounted unit basically means the entire centrifuge system is pre-packaged.
Right, all the components.
Yeah, the massive motors, the intake pumps, the electronic control panels, the vibration sensors, they're all pre-built and wired onto a single heavy-duty portable steel platform or a skid. A factory can essentially drop this entire platform onto their floor, hook up the intake and outtake pipes, and just have a plug-and-play separation plant.
And when the catalog states they build these as per process requirements, they are talking about microscopic levels of customization.
Like what?
They are engineering the specific angle of the bowl's cone, the exact pitch and spacing of the screw conveyor's blades, and the precise metallurgical composition of the steel, all entirely based on whether the client is trying to dry out highly acidic mining runoff or, purify liquid chemicals.
Because you can't spin heavy abrasive mining sludge at the same speed or in the same steel as liquid milk. These machines just have to be hyper-customized.
Exactly.
Which explains why DreamAppWorks has such a wild variety of clients. This transitions us perfectly from the mechanical realities of the machines themselves to the massive global footprint of the industries that desperately need them.
The client list in this document reads like a cross-section of global human survival.
It really does. Yeah.
We have wastewater and sludge treatment, keeping our cities habitable. We have oil and gas separation, keeping the power grids online.
And mining and mineral processing, extracting the raw materials for our electronics.
Right, plus biogas and biomass plants pushing for renewable energy.
But, those are the heavy, rugged, dirty industries. But right next to them, listed in the exact same catalog, we have food and beverage processing, dairy and starch processing, and chemical and pharmaceutical applications.
Yep, completely different worlds.
It is genuinely jarring. It's wild to see raw municipal wastewater treatment and infant milk processing relying on the exact same category of machine from the exact same supplier. How does one supplier safely bridge that massive, highly regulated gap?
If we connect this to the bigger picture of industrial regulation, it all comes down to the specialized manufacturing standards the text highlights. Notice the specific callouts for food-grade decanter centrifuges and chemical and pharmaceutical-grade decanters.
Okay, I see that.
The fundamental physics, creating artificial gravity to separate densities, is identical whether you are processing toxic sludge or producing life-saving vaccines.
Yeah.
But the physical execution of the machine is worlds apart.
So a wastewater centrifuge might be built like a rugged armored tank designed to take a beating from rocks and grit.
Sure.
But a machine handling dairy or pharmaceuticals has to be built like a surgical instrument.
That is the exact distinction. When a supplier provides a food-grade or pharmaceutical-grade decanter, they are adhering to incredibly strict, heavily monitored material standards. These machines cannot just be cast iron.
What are they made of?
They must be constructed from highly specialized, non-corrosive, polished stainless steels. And we aren't just talking about making it look shiny. The internal welds, every single joint inside that massive spinning bowl, must be polished completely smooth at a microscopic level.
Wow, polished smooth. So there are absolutely no microscopic pits, scratches, or pores where mill proteins or bacteria could hide, stagnate, and multiply.
Correct. Furthermore, the seals, the O-rings, and the gaskets have to be manufactured from food-safe or chemically inert materials that won't degrade under high speeds and leach toxins into the product.
That is so precise.
And perhaps most importantly, these food-grade machines need to be capable of rigorous clean-in-place procedures.
Clean in place, meaning the factory doesn't have to spend 3 days completely dismantling a 5-ton machine just to wash it.
Exactly. The machine is engineered with internal spray nozzles so that between batches of, say, starch or dairy, the plant can pump boiling acid, caustic chemicals, or high-pressure sterilizing steam directly through the spinning centrifuge.
Oh, that's incredible.
Yeah, the machine cleans and sterilizes itself without ever being taken apart.
That level of engineering is staggering when you apply it to the specific food industries mentioned. In dairy processing, for instance, they are pumping in raw milk and using that immense G-force to separate the lighter cream and fat from the heavier skim milk in a matter of seconds.
Right, seconds.
In starch processing, they are taking a massive slurry of crushed potatoes or corn and using the centrifuge to instantly pull the solid starch particles away from the fibrous plant water. Every single one of those processes requires a bespoke, carefully calibrated machine.
It really reframes how we view our daily consumption. I mean, the technology listed on these pages touches our municipal infrastructure, our medicine cabinets, our renewable energy sector, and our breakfast tables.
It does. And knowing how critical, massive, and deeply customized these machines must be, the logistics of actually supplying them must be a total nightmare.
Oh, without a doubt.
You don't just put a three-phase, skid-mounted chemical centrifuge in a cardboard box and hand it to the Postal Service. This brings us to the third crucial part of our deep dive, the turnkey solution. We've looked at what this machinery is and who needs it. Now we have to look at how this company actually promises to handle the immense responsibility of delivering it.
The catalog emphasizes this operational responsibility heavily under their Why Choose Dream App Works section. They explicitly state their machines are globally sourced and quality certified.
Right.
They're signaling to potential buyers that they aren't just a middleman moving inventory. They're providing complete technical support, exhaustive documentation, and global logistics coordination to ensure these massive platforms arrive and integrate seamlessly.
Here's where it gets really interesting. The text stresses a very specific holistic philosophy. They state, at Dream App Works, we don't just supply machines, we deliver complete separation solutions.
Right.
To put the scale of this into perspective, it's not like just buying a car off a lot, where you get the keys and drive away. Procuring one of these centrifuges is more like buying a commercial jet engine while the plane is mid-flight.
Yeah, that's a good comparison.
You aren't just buying the hardware, you are buying the independent safety inspectors, the custom engineering pit crew, the factory manuals, and a long-term insurance policy against catastrophic operational failure all at once.
This raises an important question regarding industrial stakes. What actually happens when one of these highly calibrated machines inevitably faces a mechanical issue?
It has to happen eventually.
We've established that these centrifuges are the beating heart of massive, continuous industrial plants. Let's walk through a hypothetical scenario.
Okay.
Imagine a massive municipal wastewater plant serving a city of 1 million people. The facility relies on a battery of sludge dewatering centrifuges working 247 to process the city's continuous flow of waste. If those centrifuges break down, the facility literally cannot process human waste.
Oh man, the waste has nowhere to go, it backs up. You are looking at an immediate environmental hazard.
Or consider the pharmaceutical industry. If a chemical-grade decanter fails due to a bad bearing right in the middle of harvesting a crystallized active ingredient, an entire batch of pharmaceutical compounds potentially worth millions of dollars is completely ruined.
Millions. Gone. Just like that.
In the industries this catalog targets, downtime isn't just an inconvenience where workers take an early lunch. Downtime is a cascading, catastrophic financial, and sometimes environmental disaster.
Which perfectly explains why the supplier's text heavily emphasizes terms like pre-delivery inspection, performance testing, and crucially, after-sales support and spare parts availability. They understand the terrifying stakes their clients are operating under.
The pre-delivery inspection is far more than a visual once-over. Before a custom-built centrifuge is ever bolted onto a shipping container, it undergoes rigorous performance testing. The engineers will power the machine up to its maximum operational RPM.
So they really push it.
They are running vibration analysis to ensure the incredibly heavy spinning bowl is perfectly balanced, because even a millimeter of imbalance at 4,000 RPM could shake a factory floor apart.
I can only imagine.
They are monitoring the internal temperatures of the bearings. They will often run simulated materials through the bowl to verify that the custom differential speed of the screw conveyor actually pushes the material as designed.
They basically have to mathematically prove the physics work before it leaves their site.
Precisely.
And once it is finally shipped across the world, dropped into a facility and turned on, the catalog points out they supply spare parts and replacement components alongside that after-sales support. Because no matter how well you engineer something, if you are spinning heavy rocks, abrasive mud, or caustic chemicals at thousands of rotations per minute under immense stress, the laws of physics dictate that parts will naturally wear out.
Right, bearings have a finite lifespan. The hardened, scraping edges of the screw conveyor will eventually dull, especially in those punishing mining or sludge applications. Having a dedicated supplier who guarantees a global network of spare parts availability is genuinely the only way a plant manager can sleep at night.
It makes the inclusion of their direct contact points in the catalog feel entirely different. Seeing their phone number, +91 78716 65841, and their email, dreamappworks@gmail.com, isn't just a polite corporate sign-off or a sales tactic.
No, not at all.
In the context of industrial-scale supply, that contact information is a literal lifeline.
It absolutely is. It means when a plant operator in the middle of a continuous 247 production run hears a strange vibration or needs an urgent replacement component, they have a direct line back to the exact engineering expertise that designed their specific skid-mounted solution.
They aren't just left hanging.
Exactly. It reinforces the supplier's promise of being a trusted partner, not just a transactional vendor who disappears after the check clears. Coordinating the logistics of shipping a multi-ton centrifuge across international borders, ensuring it arrives on schedule, and then supporting its violent high-speed operation for years requires an operational infrastructure just as complex as the machines themselves.
So to bring this entire journey together, we started by looking at a seemingly straightforward business announcement and product catalog. But by really unpacking the engineering and the applications within those pages, we've journeyed through the intricate high G-force mechanics of horizontal multi-phase centrifuges. We've seen how the exact same fundamental concept of centrifugal separation, tweaked with differential screw speeds, heavy-duty torque, and microscopic food-grade polishing, plays a non-negotiable role in our world.
It's everywhere.
From biogas and raw oil extraction to pharmaceutical processing and the dairy industry, these machines are everywhere. And finally, we've seen the comprehensive, zero-downtime supply chain required to deliver, rigorously test, and globally support these vital platforms.
Analyzing a catalog like this really pulls back the curtain on the hidden complexity of the infrastructure we rely on so casually. It is a powerful reminder of how intimately interconnected specialized engineering, global logistics, and our basic daily consumption really are.
And that brings the reality of this technology right back to you, listening to the steep dive. Every single time you pour milk into your coffee, every time you turn on the tap and utilize clean municipal water or use goods derived from complex chemical and mineral processing, you are directly benefiting from the exact type of industrial separation technology we discussed today.
That's right.
You sitting there right now are the final end user of a massive, globally coordinated operation powered by engineering suppliers, just like the one we've explored.
Which leaves you with a final, slightly haunting thought to ponder that builds on the global scale of the text we analyzed today.
Ooh, what's that?
The source mentions these machines are globally sourced and are designed to power continuous, non-stop processes. It really leaves you wondering just how many unseen, massive decanter centrifuges are spinning at thousands of revolutions per minute right at this exact second, hidden behind concrete walls in the background of your city, silently keeping the modern world separated, safe, and functioning perfectly.